what if the story of physics we've all been taught is a little bit off? Today, we're diving into a fascinating book, Newton and Relativity by Cester, Clemente, and Korff. And it puts forward a pretty radical idea that the seeds of Einstein's massive revolution were actually planted centuries earlier by Newton himself. So let's just get right to it. What if the keys to Einstein's world-changing ideas weren't some radical, out-of-nowhere break from the past? What if they were actually hidden right there inside the work of Isaac Newton? Yeah, that's the big provocative question we're digging into today. You know, for more than 100 years, the story we've been told is that there's this huge divide in physics. You've got Isaac Newton over here, the absolute master of the classical world. And then way over here, you have Albert Einstein, the guy who built our entire modern relativistic universe. And we're always taught that these two worlds are just fundamentally different, right? Newton's physics, that's for the slow, everyday stuff around us, where mass is just mass and space and time are totally fixed. But Einstein's rules, they kick in when you get close to the speed of light, where things get weird. Mass actually increases, and space and time start to bend and stretch. It's like they're two completely separate toolkits for totally different jobs. But here's the thing. The authors of our book point out, there's a little bit of a problem. Relativity, for all its power, is built on these assumptions that can feel, well, kind of paradoxical. I mean, think about it. Clocks slowing down just because they're moving? Objects shrinking in length? These ideas are proven, for sure, but they're not exactly intuitive. And that can make it really hard to get your head around the whole thing. So, what if there's a different path? A more intuitive way to get there? Well, the book argues that the key to bridging this whole gap between Newton and Einstein has been hiding in plain sight this entire time. And it's in an equation that every single one of us thinks we know. F equals ma. Come on, we've all seen it, right? Force equals mass times acceleration. It's like physics 101. It is the absolute bedrock of classical mechanics, and it's taught in pretty much every science class on Earth. But is that the whole story? What if that simple, famous version isn't actually what Newton wrote? What if we've all been using a kind of shorthand for a law that's way, way more powerful? Okay, check this out. This is from Newton's original Principia Mathematica. In Latin, he wrote that force is proportional to the change in modus, not velocitas. You might think, okay, what's the big deal? Well, the difference is huge. Modus doesn't just mean velocity, it means momentum. And what's momentum? It's basically the total amount of motion an object has. It's a combination of both its mass and its velocity. And trust me, that little distinction, it's everything. Because look what happens when you write the law the way Newton intended. As the rate of change of momentum, you get this bigger, fuller equation. The first part, m times dv dt, that looks familiar, right? Mass times the change in velocity. But look at that second part, v times dm dt. That's velocity times the change in mass. That's the piece that classical mechanics just kind of ignores. And, as we're about to see, it's the key that unlocks the whole thing. All right, so how on earth does this one little change build a bridge all the way to relativity? Well, by putting that missing piece back into the equation, the authors of this book argue that we can draw a straight line from Newton's world directly to the very heart of Einstein's biggest ideas. And the first step on that bridge? It involves probably the most famous equation in all of science. The book makes a really bold claim here, that you can actually derive E equals mc squared using only classical physics, no relativity needed. They walk through these thought experiments, using things like light pressure and conservation of momentum, which were concepts known before Einstein, and show how this idea of mass and energy being equivalent can actually pop right out of a Newtonian framework. So this gives us a totally new roadmap. Step 1, you start with Newton's full second law, the one that allows for mass to change. Step 2, you combine that with an E equals mc squared that you derived classically. And from just those two things, boom, you can directly derive the formula for how an object's mass increases as it gets faster. And once you have that, all the other formulas of special relativity just fall right into place. And all of this leads to what is honestly the most mind-blowing claim in the entire book. It goes right after the very foundation that special relativity is normally built on. Okay, so think about the traditional way we learn this. The constancy of the speed of light. It's a postulate, right? It's basically a starting rule, an assumption that we just have to accept as true without proving it. We accept it because, hey, all the experiments show it's true, and Einstein built his entire theory on top of it. But, get this, on this alternative path, the constant speed of light isn't a starting assumption at all. It actually becomes a provable principle. It's a conclusion that you can derive, mathematically, straight from Newton's full law and mass energy equivalence. It completely transforms it from a just accept it rule into something you can actually prove. So, what's the big picture here? What does all this mean? Well, it completely reframes the entire story of modern physics. Think about it. If this path is right, then relativity wasn't this sudden, violent revolution that destroyed the old physics. It was more like a natural evolution. All right, let's just recap the huge takeaways here. First, Newton's second law, the real one, is way more powerful than the simple version we're all taught. Second, the idea of E equals mc squared can actually be grounded in classical physics. Third, and this is the big one, the constant speed of light doesn't have to be a postulate, it can be proven. And all of that together means special relativity can be seen as a totally logical, even intuitive extension of what Newton started. So, we kind of end up right back where we started, with a question that really challenges how we see the history of science. Could it be that the biggest revolution in physics wasn't really a revolution at all? That by just using the full power of Newton's original ideas, we find that this great leap forward was really just the next logical step on a path laid out for us centuries ago? It's a pretty wild thought.